So it's our final set of notes for Unit 10. This is radians. So we start about by telling you what a radian is, and I'm going to try to get a little bit more in depth after I read this definition for you. A radian is a unit of angle measure based on the arc length. Y'all know what an arc length is. It's the length of an arc, a piece of the circle. 1 radian is defined as the measure of an angle formed when the radius is equivalent to the length of the intercepted arc. Recall the circumference of a circle is 2 pi r. Now they use it as 2 pi r. You know, I do pi times diameter, which is the same thing. 2 times the radius is diameter, so either one of those will work, pi times diameter or 2 pi r. But I'm going to talk about 2 pi r right now. Before I get into this stuff down here, the conversions, I want to talk to you about a little bit more about what a radian is. Some of y'all might get it, some of y'all might not. But, alright. So, like they said, they consider a radian to be the angle formed by a radius and arc being the same length as that radius. So, say if I was the radius of any circle that I have, say my radius is, I don't know, I'm just making a number up, 8 feet. They're saying 1 radian would be equivalent to 8 feet wrapping around the circle right here. And like, that's why they got R here and R here. They're saying these two lengths are the same. So say if this was 8 feet, this would be 8 feet as well. Let me zoom in. And they're saying it's always the case that and the degrees created by that is going to be pretty much the same every time, created by 1 radian. Where they get the number pi from, that 3.14, they feel like half of the circle, which is 180, is 3.14 radians. So let me show you what I'm saying. This is 1 radian right here. This little piece of the circle. 2 radians would take me about right here. That'll be 2 radians. 3 radians would take me almost to half of the circle, about right there. That'd be equivalent to 3 radians. This would be a radian. This will be one here too. 3.14 gives me half of the circle, 180. That's where the pi comes from, 3.14. So it's basically 3.14 radians is pi. So whenever we're using pi in the calculator, that's what it is. It's represented as 3.14 radians. And then it's times our radius, because whatever our radius is the length of a radian. So if we got an 8-foot radius, that means our 1 radian is 8 foot on our circle. If we had a radius of 10 feet, that means one of the radians on the circle, this curve right here, would be 10 feet. And so on. If it was 5 inches, it'd be 5 inches right here, plus 5 inches, plus 5 inches, plus 0.14 of a 5 inches, or whatever. That would give you the 180 of a circle. The times 2 is because we only got 180. Times 2 will give you the whole circle. That's where the circumference formula comes from. Don't know who figured that out. Don't care who figured that out. But that's where the 3.14 comes from, if you ever cared. And that's where we find circumference of a circle. That's where it comes from too. 3.14 is the amount of radians that would give you half the circle. It's just the radians times the radius, whatever the length of it is. Alright. Just want to give you that little nugget if you care for it. Oh, the other thing too, and on your calculator, I said, you know, I just told you our format had to be in degrees. Like I said, one of those other formats was radians. You remember when we did trig, we couldn't have it in this form because it was giving all our answers wrong, because it was calculating based off radians and not of degrees. We're gonna convert ourselves from radians to degrees and degrees to radians today. I'm gonna show you how to do both. Not hard doing it on paper and by hand. It's pretty easy actually. Alright. So 2 ways you need to convert is converting from degrees to radians. If they give you a degree to get to radians, you just want to times your degree by pi over 180. And in reverse, if they give you radians starting out with, you want to times by 180 over pi. That'll take you to your degrees. It's just vice versa. This is the one we mainly going to use. We want to show you how to do both, because what the issue is going to be, they're going to ask you to find arc length and area of a sector, stuff you've already done before. But the angle that they give you, that central angle that they give you, is going to be in radians. It's not going to be in degrees. If I go to the back real quick, I'm going to show you what I'm talking about. So these problems on the back, if you look at all of them, they don't give us a degree on our circle. They give us radians. This is 3 over 2 pi radians. Then they give us this angle as 7 pi over 4 radians, and so on down here. They don't give us anything in degrees. We have to convert this to degrees, which is not hard to do once again. For those who are going to go further in their math, which is some of y'all, some of y'all might even take pre-cal here. Or you definitely take it in college if you go to college. Y'all going to get introduced to the unit circle. The unit circle, let me zoom out. This shows you kind of the base degrees. It's not all of them. It's just the main ones we use. It shows you the main degrees and the conversion to radians for each one of them. Like 30 degrees would be pi over 6 radians. Well, let's start here. I told you that pi represented 3.14 radians, and that was half of the circle, 180. So that's why right here at 180, if you could want to convert 180 to radians, it would just be pi, because that is half of the circle, 3.14 radians, which is pi. Pi is 3.14. But the other ones they show you in here, they used to try to make us remember this in school. I think you have to remember for pre-cal, because they just want you to quickly be able to go back and forth and be able to tell radians. This stuff right here, I don't even want to talk about that. This is pre-cal stuff too. We just bouncing back and forth between radians and this. This has to do with secant and cosecant and tangent and stuff. That has to do with trig stuff. Gets a little crazy. But we only writing here today. We just going back and forth between radians and degrees, and it's not hard to do. But like I said, at some point y'all gonna get introduced to the unit circle. You might not like it, but I ain't never like it. It took me a long time. I still don't remember all of it. I have to look at it every time. Alright. We're not going that heavy. I'm just going to show you how to convert stuff. So we're going from degrees to radians first. So 30 degrees, to turn that into radians, I want to use this conversion up here that they gave me. I'm going to take my degrees. Let me see how I did my notes last time. I like to stay consistent. Well, we can just leave it there. They already got it written. 30 degrees times, and then like they said, pi over 180. So essentially, I mean, some of y'all need this data to make y'all feel better. You put a 1 under there, you just multiplying straight across. On top is 30 times pi. On the bottom it's 1 times 180. So 30 pi on top. On the bottom you get 180. Then after that we would just need to reduce this. Let's try to think of big numbers today, so I won't be here all day reducing. What's the biggest numbers you could think of to reduce these two? What again? Yeah, 30 will go into both of these. 30 will go into itself, and it'll go into 180. On top, 30 divided by 30 is 1, so 1 pi. On the bottom, 180 divided by 30 is what? 6. Last thing is, we don't ever, if it's ever a 1 on top, we don't never write that. We would just write it as pi over 6. This is us converting from degrees to radians. Let me show you on my unit circle. So this is one of the common numbers too, so you'll see it on here. On the unit circle, 30 is pi over 6. So this is how you would get there if you had to convert by hand. Some of your degrees will be negative. That just means you're going to have a negative radian. That's fine. This next one, 220. So times pi over 180. So on top I get negative 220 pi. On the bottom 180. And then we need to reduce. Jeremiah, give me a number. Give me a number, man. Yeah, 20 should be good. Come on, Jeremiah. Divide by 20, divide by 20. What's this? What's that, 11 on top? Negative 11. Don't forget the negative sign. 5 over 9. At negative 11 over 9. I don't think 220 is one of our ones on my unit circle. It's not one of my common angles. If it was, it'll fall right in here somewhere. But it's not one of my common ones, so you ain't gonna see it. Do the next two. I don't want to do them. This stuff don't work. Oh. Alrighty, we should be done. Swan, what you got on number 3? Huh? Say it one more time. On number 3? 10 over 4? 12 over 4? 10 over 12. 10 over 12? You think you went far enough with that? It's still, even that. 10 over 12 can be reduced. Should be 5 pi over 6. I was saying, if you don't pick a big enough number, you're going to have to reduce again. You got to get it down to the smallest form, which is 5 pi over 6. I think this one is on my sheet too. Let me see, is 150 on here? Yeah. 150 is on my unit circle as well, so it's there. It's 5 pi over 6 right there. Make sure y'all simplify now. Lucia. Number 4, what you looking like? Okay. Vince, you had your hand up?
What's the face at the go? Emily.
Let me.
I got negative 7 over 9.
Oh, good, Vince. Hold on, you didn't say the whole thing, though.
So negative 7 pi over 9.
There it is. Negative 7 pi over 9. You coming from testing? Ain't getting no pads? I'm recording it, please. You just drop it. Alright, let's keep it moving. I want you to know how to go from degrees to radians, but honestly, the path you're going to have to take is this path right here. This is the path we need to go. We need to be able to go from radians to degrees, which is not hard, just reverse of what we just did. We just undoing the radians. Guess me hit number 5 and number 6. So from radians to degrees, it's times 180 over pi. And then on top, it's 4 times 180. Oh my God. 720 pi. On the bottom, it's 3 times pi, which is 3 pi. What's the first and most obvious thing that's going to happen right here? The pi's are going to cancel themselves out. Yes, they are. After that, you just need to do 720 divided by 3. 240. So going from that to that, my degrees will be 240. I think this was on my sheet too. Yeah, it is. So looking at my unit circle on here, 4 over 3 pi, if you want to go, is 240. Like I said, on the unit circle, the common degrees on there, like the common ones you kind of use all the time. Now this one ain't a common one, I can tell you that, so it ain't gonna be on the unit circle number 6. But we can easily get it. Just don't forget your negative sign. I always carry my negative. I told y'all this when I started teaching y'all at the beginning of this year. Carry your negative sign with the top of your fraction. Don't carry it on top and bottom. You don't want to do that. Carry it with the top. Yeah, get it. People come from testing. Oh no, it ain't. Alright. This one is, so when I do this next one, I'm doing negative 5 times 180, or negative 5 times 180. That's going to give me negative 900 pi. And on the bottom, I'm going to get 36 pi. The pi's cancel. They do. Negative 900 divided by 36. Negative 25 degrees. Oh, I can leave that there. Do number 7 and 8. Hurry up, we should be fast on this now. Devin, what you got for number 7? Shh, hey, just save me on. That's why I ain't gonna let you go nowhere. What now? Yeah, 315. Alright. I know I could. I just know you know. I'm bothering people out. Thing might be a little shaky. Let's see what you got for number 8. Yeah. Yep. And only one I want to mention is 90 degrees. It makes sense for that pi over 2 to be 90 or negative 90. Is because pi itself, if you ever got pi, that would be 180. Pi is 180 degrees, so half of pi would be half of 180. That's why I think, well, I ain't gonna go that deep with y'all.
Go deep.
I'm saying pi divided by 4 is gonna be 45, because it's like a quarter of 180. And then pi divided by 3 is 60. It's a third of 180.
I knew that. That's obvious. You don't know that.
I don't know.
You gotta be stupid.
Not stupid. Y'all just ain't been introduced to this shit. Fellas, let me get through this. Y'all messing up my video. Matter of fact, just save me. I need the formulas on the back for area of a sector, and then we can do arc length. You can do both. Yeah, if you get both of them right.
A equals x over j times pi r squared.
Oh my god.
What's the power square part on this?
The diameter.
What?
I mean, no. The circumference.
What? No.
You trying to go to the bathroom, right? Let me ask you again. Pi r squared part, what is it?
Oh my God, bro. We just learned it.
So, the area. The circles.
Alright.
Oh my God.
Shh. Go ahead, give me arc length.
L equals K over 360.
L equals what over 360?
X over 360 times 2 pi r.
It's not the one I use. I told you I don't use that one. Yeah. What is that anyway?
You said what?
What's this?
Circumference.
Alright. Alright, so y'all can use 2 pi r. I told you why I don't, because y'all get it mixed up with this. I don't like writing it. I like it to look different. Alright, so down here we're going to find the length of an arc for 9 and 10. And then 11 and 12 we're going to find the area of each sector. And then 13 and 14 are going to be word problems. You're going to have to decide what you're going to do. Whether you're going to find the length of an arc or area of a sector. Number 9, I'll do this one with you. You can do number 10. Number 9, they give us this arc right here in bold, I guess, that they want us to find. And they give us the degrees in radians. It's 3 pi over 2 radians. Our radius is 16, so we can roll with that. First thing you want to do is convert from radians to degrees. So I'm going to do 3 pi over 2 up here times 180 over pi. Three times 180. Oh, I can't remember. Is that 720 here? That's 540.
What?
It's 540 over 2 pi. Cancels. Divide 270. So that's 270 degrees. And honestly, that makes sense. Looking at this right here, what angle is this right here on this other side? A 90-degree angle, right? It's a right angle. 90 minus 360.
Oh, you did it.
It's 270. I mean, just a way to just show you that we're correct. That's 270 degrees. All right. What do you mean? How would you check it? I just showed you. Girl, go ahead, back it up. Alright, so we're using arc length formula. L equals x over 360 times pi times diameter. L equals, we just found our x, which is 270 over 360 times 3.14 times our diameter, which is what? 32. Round to the nearest hundreds. 75.36 feet. Yes, it is. Cool beans. Do number 10. 10 should be faster. Yeah, go do the thing, please. Stop talking so much on my video. I'm gonna wait. Then I unpause you. Boy, hey, what you got?
9.45.
Sound like you might have rounded wrong, but you're close. Unless I rounded wrong. Who rounded wrong? Me or him? Huh? Him? Okay. What we got? 49 point what? 46. There it is. Number 11. Huh? Oh, shh, be quiet, man. Let her be. Let her be. Number 11. Find the area of a sector. So on this one, 17 pi over 12. Converting that, it's 180 over pi. Oh Lord, it's gonna be a big number. 17 times 180 is 3,060 pi over 12 pi. The pi is canceled. 3,060 divided by 12 is 255. That's 255 degrees. And then from there, K equals X over 360 times area. So K equals X. Oh, why am I saying X? 255, my bad. Over 360 times 3.14 times our R squared, 14 times 14. They round to the nearest tenths on these. 435.9. This is feet squared since we're in area now and not length no more. Oh, yards. My bad, yards squared. Obviously do number 12. And one more time?
78.5.
Yes, sir. 78.5 miles squared. If you ain't got that, rework your problem. $13. Now, I've told y'all this since the beginning of the year. We on our last set of notes. If you want to know how we're going to ask you questions based on a certain topic, look at the last couple questions of your notes. Obviously, we're not going to give y'all just a circle and ask y'all to find arc length or area of a sector. We're going to give you a word problem, and you're going to have to decide what you're supposed to do. So we're going to let Vince make the first decision. Vince, listen to what I'm reading and tell me what I should do. It says a wire is running along the side of a circular building covering 270 degrees of the building. How long is the wire if the radius is 5 yards? Vince, which formula should I use? Should I use area of a sector or arc length? Say it again?
Arc length.
Why?
It's the outside.
You don't say nothing about outside.
It's like on the side.
Along the side? Yeah, just say that. Yeah, it does say along the side. Then the other thing that tee you off, Vince, it says how long. Length is long, right? Yeah, how long is the wire? And this is arc length. I say this because the main issue I have with kids on the test, half of y'all be using the wrong formula. Use the correct formula, please. It's arc length. This is the one with the L. Let's roll. So, on this one, too, we don't even have to do a conversion. It tells us degrees. L equals X over 360. I guess I'll write it out. That's because I always do anyway. Pi times diameter. I know y'all not because y'all lazy. L equals 270 over 360 times 3.14. Vince, what's my diameter? Thank you. They don't tell us how to round, but let's stay consistent like we did up top. Let's for arc length, let's do hundreds. Okay. 23.55. This would be just yards. Let's see at number 14. It says a water sprinkler sprays water over a distance of 30 feet, rotating through an angle of pi over 18 degrees. What area of the line receives water? Let's see, which formula am I using? Say it again. I don't know what that is. Say it one more time. I feel like you mixing it. You're saying two things. You said arc of a sector. That's not anything I know. I know that ain't what it say up there.
How do you want me to say it? It's an area of a sector. Area? Oh, you're right.
It's all good. All right. How you know this area of a sector?
Because we just did
So you assuming the other one is going to be area?
yeah.
Okay. Well, go ahead. Yeah, it says area in here. You could have just told me that. Oh my God. First thing you need to do on this one is do your conversion. You need to get to degrees. So it's 180 pi over 18 pi, which is easy. Cancels. 180 divided by 18 is going to give you 10, I think. 10 degrees, yeah. Alright. So we're doing arc of a sector according to some people. So it's 36 pi squared. K equals 10 over 360. The fact that you're doing 10 over 360, I'm going to tell you right now, your number's going to end up being, well, actually it's not that small, surprisingly. I think because our radius is so big. What is our radius? I'm sorry?
15.
I say 15. Y'all know how a sprinkler works?
Oh, 30. Wait, am I?
If we thinking of a circle, Billy, the sprinkler, where would it be on the circle? In the center, right? So the water spraying out would create what? The radius. I'm not talking to you. I'm talking to people who said 15, sweetheart. Round to the nearest tenth on this one. Go ahead. 78.5. This feet squared. Cool beans. Well, guys, congratulations. We have made it to the end of our notes for the year for geometry. Our last set of notes.